And now, to share a little bit of knowledge, Francisco Almada Logo from Critical Manufacturing.
Hello, good afternoon. Is it working? Can you hear me? Yeah, okay. Pretty good. Just my presentation is not yet on. Or do I need to press it? All right. Good. So, thank you very much for being here. It's really a pleasure for me as well. My talk's going to be a little bit different from most of the others that you've seen or that we will see today. I will talk about the fourth industrial revolution, which is a topic that most of you has heard already. And I'm going to talk about why is it all about software and what types of software. So I will start by showing you that this was my first computer. For most of you, this belongs in a museum and you've never seen one of these. This was a PC Amstrad 1512. And it was really funny. You had to load these in floppy disks, load the OS, then I had to load the program that I wanted to work with. At the time, I think it was QuickBasic or something. And so I liked software from very early days. After that, I joined the FEUP University, although not this university, but the university in Rua dos Bragas. It's really amazing how it looks so old when looking at these images. And I went into engineering, and there was no software course at the time. But I had some contact with computers at the time already, and there were some nice disciplines already with programming computers and so on. I remember having a professor who used to read code 60 minutes. During the entire 60 minutes, he would just simply read code from the beginning of the class until the end of it. So it was really funny. And I had my first contacts with email. This was my first email client. It was called Pine. I'm not sure if any of you already used one of these. And it was really funny. I used to go to Pine once per week. And I had like 2 emails per week in average, which was not bad because I knew 5 persons that had email at the time. And 3 of them were in my class. And I had a cousin who had a Macintosh, and he could send me a few emails at a time. It was actually very interesting. The first email that he sent me, he put the entire message in the subject line. Because he read their subject, he said, okay, that's it, it's here, and he wrote it. So, very, very nice. After graduation, I decided to work in the industry, in manufacturing, in factories. This is what I loved. And I always looked at software as a means to a domain that I really loved. And this is kind of a message. I mean, there are brilliant software engineers. Some of you here are brilliant software engineers, but you can be even more brilliant if you dedicate to a domain, to a certain area that you really love. So I worked in an R&D institute called Centro SIM do Porto, which doesn't exist anymore, but it had lots of robots and computers and so on, and it had automatic guided vehicles. So this car, the small car that you see there, and what I did was programming this car. It looks very great, except that I used this computer to do it. It was an Alpha Digital machine running VAX VMS, and I did programming in Fortran and only later in C. Okay? So fortunately, things have evolved, and I started working for Siemens around in the 90s, which later became Infineon and Qimonda. There are a few persons here that come from this world as well. And I mean, here I could do great stuff. So I had my own Visual Studio, I could do my own programming. There were not many rules about what you could or not do, but it was really great. And recently, I work and I founded Critical Manufacturing, and we do a lot of stuff great in terms of software and manufacturing. Now, of course, I don't program anymore. I'm not sure if you're familiar with the Dilbert principle. So the Dilbert principle means that you are promoted until you reach a level that you cannot do any damage anymore. Okay? So that's basically me. Nobody allows me to code directly anymore. But so one of the things which is interesting in this area is that for a very long time, it was very difficult to convince people from the software business that manufacturing was a great area to work for. So manufacturing was never very sexy. Of course, I talked yesterday to a couple of friends, good friends, and one of them worked for insurance companies. Okay, and that was not so great either. So I felt a little bit better then. But all of a sudden, software and manufacturing became sexy again because of one particular thing that happened, which was the World Economic Forum in Davos, where it was announced that the fourth industrial revolution was coming. And basically the news said something like, you know, because of robots, and we'll speak later again about this, something like 5 million jobs will be lost within 10 to 15 years. And so everyone panicked and everyone wanted to know what was this revolution all about. So, because it was the fourth revolution, it means, of course, that there was a first, a second, and a fourth. Just briefly, so that you are aware of all this, the first industrial revolution was created by the introduction of mechanical and steam-powered engines. So before, everything was manually handicrafted, and so it was manufactured for the first time upon the first industrial revolution. Second one was created because of electricity and the division of labor. The most known case is the Ford Model T, where all of a sudden there were production lines. The third is when electronics and robotics started to happen. Okay, so if anyone says to you that the fourth industrial revolution is all about robots, now you know it's not true. And you know, 9 out of 10 person that you ask, you're going to say this. So robots is the third industrial revolution. So what is this fourth all about? It's about cyber-physical systems. And I will decipher this term later on. So everything started with Frau Merkel. Here she is, holding a robot's arm, I suppose. And basically, you know, everything started with the fourth industrial revolution and the Industry 4.0 by a certain German arrogance. So they said, we dominate manufacturing worldwide. We are the best in terms of manufacturing. There's going to be a revolution. We're going to still be the best in the world doing this, and this is our strategy. And they basically told what their strategy was to the entire world. Okay, this was what created all this fuss around this topic. And so the Industry 4.0 needs two aspects at the same time, demand and supply. And let's start with demand. And demand has to do with a movement that started from mass production, talking about this Ford Model T, where you can have the car in any color, so as long as it's black, into mass customization, in which we all want our watches or our mobile phones to have special personalization characteristics, to think that this is unique for us. Of course, you know that's not what's happening today, because what's happening today most of the times is just that it is painted differently, it has some finishing materials, but basically the product is basically the same throughout the entire process. Now, this is going really into a direction in which products are becoming more and more unique. This is a case I really love to show, which is a Nike shoes website in which you can configure your own shoes. I'm not sure if you've seen one of these lately. These have evolved greatly over the past couple of years. And right now, you can configure your shoes with different colors, with different materials, with different shapes. You can have a left shoe which is different from the right shoe, different sizes if you want. So you can do all of this. And so what's interesting is that once you click the buy button, there's a production order and there's a factory, probably in the other side of the world, that has to actually manufacture this. Okay? And so this is the demand part. At the same time, we have the supply part. And the supply part, this revolution has been caused by what we call technology enablers. And the first technology enabler is actually not software, but hardware. So all of a sudden, it was possible to, in a chip like this, so this is a 1 centimeter chip that has, in this case, 64 nanosensors. Okay, you can see the miniaturization that electronics has achieved today. This is another example. This is a MEMS, manufacturing actuator, and this is actually a movement detector device which occupies a volume of 1 cubic millimeter. So this was the driver for the so-called Internet of Things, which in manufacturing is called Industrial Internet of Things. And this became so small, so affordable, so cheap, that it was possible to attach it to any product. And that's basically the part of revolution. So if you have a factory, and if a factory has machines, materials, robots, transportation systems, whatever, if all of them can have one of these small electronic devices, then they can not only have a certain intelligence, having sensors and actuators, but they can also communicate their status to the outside world. And so there is a digital twin, meaning that there is a virtual world that represents the physical world which happens. So of course, immediately, if you have this, you have all the scenarios that you need for virtual reality or augmented reality scenarios, in which basically you can add virtual information, software information, to what is being seen physically. And so this is one of the areas more important in terms of software for the manufacturing area, which is the connectivity and mobile. The second one is, of course, big data. This is a typical consumer packaged goods facility that is said to create 4 trillion sample data points per year. So you can imagine the amount of data which is created in factories these days. And so the ability to work in big data algorithms that can really transform this data into decisions, and that at the end can make some factories be more productive and can help some factories survive while others will not, is heavily due to the big data analysis. And so cloud and advanced analytics is a second area. Now, the third area is the one which is more interesting. This is now the core element, the cyber-physical systems. What this means is that this small device, and let me try to use my mobile phone to show you this. Let's imagine that I am in a factory using a mobile phone, and the mobile phone is not yet built, so I have a case. The case is a little bit dirty, sorry for that. And I can have one of these electronic devices attached to this. Okay, and this electronic device is able to have some computing power. He has some sensors, so I know what's happening there. It is connected to the internet, and it is responsive, means I can have actuators in this. So this is called a smart product, but the product is not there yet, right? However, in this case, this is like the representation of this mobile case, knows exactly what is to be produced here. So it is the product, it is the case that's going to say to the different machines in the production line what it needs to be produced in the future. Okay? At the same time, you have machines. I don't have machines here, but let's imagine that these two screens are the machines. The machines are also intelligent. They have one of these chips here, and they are intelligent, aware, connected, and responsive, so they are smart equipment. There's a virtual representation as well of this equipment at the same time. And so, this is now our complete factory. And our complete factory has products already built or in this situation, and it has machines. And this is the virtual representation of all of them. And because they are intelligent and they are autonomous, they will speak to each other. This, my friends, is the fourth industrial revolution. And so what's going to happen in the production line is that, now coming back to this example, this is a future mobile phone, and it needs that the first step of the production will be, for instance, to build a hard case. And so it will ask to different machines, what is the price for this operation? So the factory itself is becoming a marketplace. And the different machines will say their price. Some are not available, some cannot build these type of things. Some others are more expensive because they need setup or schedule, and some others are already ready and are cheap. And so, I will choose this one, station 3, and this will be produced by this machine. So I will talk to the machine, and the machine will start producing, and then I'm going to move to the next step. So far, so good? Good. So this is now my shop floor, where everything is talking to each other. And it are the products, it is actually the product that is controlling everything, even before the product really exists. So this is called logical decentralization, and this is one of the greatest areas of investigation in software in the manufacturing of the future. There's another step which is important called vertical integration, which basically means that despite the fact that we have materials talking to machines, We have processes, of course. We have processes in the factory. We have quality procedures. We have engineering processes. And so this negotiation cannot happen directly. It has to go through a step of processes of the machine, and this is called the vertical integration. Now, the thing which is also interesting here is that what happens within the factory in the Industry 4.0 shall happen in the entire supply chain. So the same marketplace that happens within a factory is going to happen in the entire supply chain, where we have a customer requesting something, and then all the factories will bid to see which one will actually build the product. And then we'll have an abstract concept called supply chain control tower, who's going to know exactly where our product is. And so whenever someone asks for something like this, what's going to happen whenever someone, going back to the Nike shoes example, when someone clicks the button, you're going to know in the future exactly where your product is. So it's not like what we have in Amazon today, which says things like, you know, it's in the warehouse for 2 days and likely between the warehouse and your house. No, you're going to know exactly where it is. And you can even have in the future streaming video that shows your product being manufactured. So we're not so far from that reality. One thing that I did not explain that has to do with one of the aspects of this is 3D printing or additive manufacturing, which is also important, in this case related to prototyping. Because imagine that you're building one of those Nike shoes, you can build a shape that doesn't work out. And so someone needs to prototype it and see if it works, and this is the role of 3D printing in this stage. However, 3D printing is evolving really rapidly, at a pace that nobody really understands or knows exactly when this will become actually the 5th industrial revolution. In this example, this is a prototype example, you have already printing machines that can print 7 different types of materials at the same time. And they can print with an accuracy of a half of a human hair, which means that today it's going to be already possible to print the electronic tracks directly into the material, into the body of the material. Okay, so this is going to be really a revolution. It is happening so fast, sometimes you don't understand it, but I'm not sure if you know this company called 3D Hubs. You can already today grab one model, upload your model, your CAD model or similar, into this platform. You can select the material that you want, and then you can check how many printers you have available, and there are dozens of printers already available in the Porto area. Okay, you can do this today. This is great for unique Christmas gifts. Okay? Probably not very expensive. Of course, you know, what's going to happen is that since everyone can do anything, you're going to have things like this. You know? This is really horrible. This is an example from Daihatsu, in which you can actually specify entirely, and you can have shapes and textures into your car. Okay? So the tuners are going to have really a very good time in the future. Okay, then the final thing, and this is probably an angle that you never thought about. You always seen already drones from Amazon testing, delivering products to the house of the consumers. What you did not know is that it is actually the product that is telling the drone where to go. Because remember, the intelligence is all here, not in this cover, you know, that's in there. Great, so this is called horizontal integration, which integrates the entire supply chain, and it's yet another area of software for manufacturing which is really important these days. And then it goes even beyond that. So it does not stop when we deliver the products into the customer. It continues as the customer uses it. This is me. I don't see you can see me. I'm a little bit dark here. Driving a Tesla. So I did a Tesla Model S driving experience some days ago. It was really cool. Those that you cannot see are my jealous friends there. And you know, this car is all about software. This car has a big console, has almost no buttons to click except inside the console. It's all software, and I actually tested the autopilot and it worked great, despite some things that you probably know that 2 days ago there was a person killed. We can talk about this later. So there's still some way to go there. But you know, it's really great. You know, I've seen the future. I will never be able to drive a normal car again. So I will start saving. But what's important in the Industry 4.0 is that, you know, once this is, okay, now this is not the case anymore. It's already a built product. Once this product is built, it will continue to transmit, it will continue to send information And this information is very useful. Okay, let me take this example. Okay, I just wanted to do that. So what happens here is that because it is still transmitting data, there is things that can be done. And there was an example with Tesla which was really great, which was they have a universal charger, and the universal charger was overheating. And they could understand that it was overheating because they were receiving the readings that were coming from different sensors, right? And because this was happening, what they were able to do was they did what? A new software version. Yes, a new software version to the car, which would reduce the current by a certain percentage, and that eliminated the overcharging and the overheating. And so by doing this, and all that they talk was, there is a software update, please click the button to set it. The drivers would click the button, not while they're driving, but while they were standing. They would click the console, and there was a software upgrade, and the problem was solved. You know, instead of what you currently hear with other brands, with classical brands, like Toyota a couple of weeks ago, they had to recall 1 million vehicles, okay? In the future, this is not gonna happen. And so this is the Industry 4.0, you know, everything started here, and then it went down to the end of it, down to the end customer. This is the Industry 4.0. Thank you very much.
So, any questions? Not about building cars, please. The tuning version was appalling. No questions. One question over there. Okay, George.
Be careful what you're going to ask.
Hi, Francisco. Congratulations on the presentation. Very interesting. Although I think it was the only person that until now, you have much more that in planes and etc. that are automated at this time. In Tesla, you only have one until now, right?
Sorry, you have to speak.
In the Tesla accident you had, there were only one person until now that you had an accident.
Yes, yes, as far as I know, yes.
Millions of kilometers already run,
yes.
So it's much more safer than other
Actually,
automated.
130 million kilometers. And nobody knows exactly what caused the accident, but it seems like the pattern recognition software on one side confused a tractor trailer with the sky. The sky was very bright, so it could not detect it. And something happened because the trailer was high. Even the sonars did not detect the trailer. Okay? So what happened was the Tesla car crashed beneath the trailer part of the truck.
Okay, my main question was about you haven't.
And by the way, there's something just very, very quickly. What happened there as well was that it was found that he had a portable DVD player. Okay, so he was using the autopilot and he had a portable DVD player. I tested the autopilot, and what happens is that because it is everything automatically done, every X minutes the car starts beeping and requests you to touch the wheel, the driving wheel. And you only have to touch the driving wheel for a couple of seconds, and then you drop it, and then it continues. So it's very difficult to understand what happened there, but I think we're going to hear lots of this, about this over the next days.
Okay. My question was about, in terms of threats or weaknesses about Industry 4.0, what do you see as threats for this? And if you ever discuss this on how do you see the next generation of Industry 4 point something or Industry 5 point something?
Yes, so again, the Industry 4.0 is happening now, and it's not going to happen from day to night. So all of these things about the cyber-physical systems are expected to take 10 years, 15 years, 20 years. And so there's a lot of, you know, especially in terms of software, there's a lot of development ahead of us. What I believe, but this is my personal opinion, and we can talk to each other like in 30 or 40 years, see if I was right. I think the additive manufacturing is going to be the next revolution, because today, because of the speed and so on, you can only do prototypes and so on. But in the future, you'll be able to do your own products using these 3D machines. So there's not going to be any factories anymore. You know, simply put, you're going to have factories for, you know, raw materials, perhaps. You're going to have factories that build the 3D printers, but probably not much more than that. You know.
There was one more question over there.
I want to challenge your view for a little. May I have permission? For all the hype about the fourth industrial revolution, when you look at the data, at the productivity per worker statistics, that doesn't appear anything. It has been stagnant since the 70s. What do you have to say about that?
Well, first, I don't know where you take those statistics from.
Excuse me?
I don't know where you're taking those statistics from. The factories today are incredibly more productive than they were some years ago. Incredibly. Okay, we cannot confuse, of course, the Portuguese industry with the overall industry. Everyone in Portugal talks about Industry 4.0, and the majority of the factories are still managing production with paper and Excel sheets. Okay? I know it's Excel sheets, and I know Excel is in the computer, but that's not what I call digital factory. Okay? In all the others, there are huge productivity increases out there. But the important thing here is that since you're going to have products that are really unique, and this is the fundamental step, if the products are really unique, there's no need for a centralized system who automatically optimizes the production floor. It will be impossible to centralize, in a centralized way, optimize the production line. And so that's why we have this model of agents and marketplace. Okay? Of course, you can say we haven't seen it yet. Yes, I mean, for the time being, most of these things are theories. This factory that I showed before, it's actually a Siemens factory in Germany, near Hamburg, that actually has the Industry 4.0 concepts implemented. But when worldwide, we're talking about 2 or 3 factories worldwide, so it's still a little bit early to find out. But at the end, it's not like it's more productive. It's like there will be factories that can do these unique products, and there'll be the others that will not be able to do those. And the ones that will be able to do will survive, and the others will probably die. It's going to be as simple as that.
Still, if there was being a lot of automation, there would be a lot more productivity growth, and there hasn't been since 73.
Yeah. I was born in 73, and there's a lot of productivity improvements since then. But
not compared.
No, but the problem is that the robots, how they are built today, and that's why this is the third industrial revolution. The robots, how they are today, and the automation how it's done today, it's done to build the exact same products over and over again. Okay? So when you start having small series and you start having one-off products, then the same level of automation is not working anymore. It's not by surprise that there is, for instance, one discipline which is outstanding, something, it's not possible to talk about everything about Industry 4.0 in such a small time frame. But you have cases, for instance, when we have collaborative robotics. I'm not sure if you heard about this already. But basically it means that things will be so different that the only way will be to have the most resourceful and flexible resources that exist, which are humans, doing something new, and then having robotics that learn from humans and that start doing the new products right after that. So these are all ways that are necessary to cope with the flexibility which is needed for the future manufacturing.
All right, seems plausible.
Thank you so much.
One more question over here.
I'm not sure we're very convinced, but we can exchange some emails later. Okay.
Just have to learn about uniqueness and things about the difference between.
Hi, Francisco. Thank you very much for your presentation. It was very nice. I was just wondering, on a more social part, that you said that 5 to 10 million jobs will be lost. Do you think that the governments and like lobbyists will prevent this to move faster? Or do you think on a revolution side, the industry will overcome that?
I think that whenever there's a revolution like this, there is such an increase in terms of the overall productivity and therefore in terms of the economy that at the end there are more jobs for everyone. If we imagine what happened during the first industrial revolution, you know, all of those persons that used to do everything by hand will be jobless from day to night, right? But so what happened was that because the economy grew, at the end there were more jobs for everyone, right? What's going to happen is that the jobs will be different. And there'll be persons that will need to adapt, And there will be some negative impact for some persons that will not be able to adapt. But again, this will be slow. And so as the new generations come into the job market, they will be more adaptable and more ready to take these type of jobs, while the older generations will have to adapt or still remain in the existing jobs, classical jobs that will still exist.
That was the point that I want to come. I was just wondering how far do you see it coming in your experience?
Maybe I haven't lived enough there, but I would say that's 15 years, less than 15, 15. Nothing will happen so dramatically that this type of things like 5 million jobs will happen.
Thank you.
There was one more question, two more questions over here.
I don't know why the red light is blinking. Under control. Okay. All right.
That's my problem. That's my problem.
So considering the concept of this Industry 4.0, in which some sort of AI controls these machines and all that, how much thought and if any conclusions have you given to Doomsday scenarios like Skynet, or even things that may be like not so apparent, like a super AI that does everything better than us and makes us irrelevant? Have you given any thought to that?
Yes, I don't think it's going to happen. Of course, there will always be persons that do this, and I think this example of Tesla is a perfect example. I drove this Tesla and I was puzzled with the autopilot thing. It could read the signs in the auto-way and say 120, and so it would automatically tune to 119 kilometers per hour, and it would drive within the lane marks. And if there was a car in front, it would automatically stop, and then when the car would go out, it will accelerate. So everything seemed perfect, yet there was an accident. See, for example, the Google auto-driving cars, which is one level upper than that. They are testing auto cars for, 3 years, 4 years, really running in the streets. There was almost no accidents, but there are still, there was an accident some months ago. So I think we still have a lot to go. So I don't see, there's going to be a lot of advancement. There's going to be different speeds of evolution. I think, the Doomsday scenario is not likely.
So you think there's a limit to the evolution of these things?
I don't think there's a limit of evolution. I think there's a limit in pace of evolution, which could be the same.
There's one more question.
Hi, thanks for your talk. You talk a lot about 3D printing. What I'm about to tell you is, do you think about self-assembly products like there is in bionics and materials that are inspiring in biology and other phenomena? What's your opinion in self-assembly products, for example?
It's not an area that I'm specialized, so I'm going to have just an educated opinion there. I think that I have seen some of these things happening more in studies and more in prototypes than in real life. Of course, the ability to go one level upper, which is having intelligence to build itself from the scratch, is likely something that will also take a lot of time. We're going to hear some of the things that we see, and there's a lot of, we are in the marketing area, in the marketing age. A lot of the things that we see are not really real today in our futurology. So some of these things will happen, but none of these realities still exist today as far as I know. Okay? There are examples, there are prototypes, not more than that. And so I think this is going to take a lot of time.
Yeah, but I saw some articles about electronics that are built and triggered to be dopped in some occasions, like temperature or other things, and they are assembled by that micro triggers that they have.
Yes, but that's not very, it is intelligent, but not that intelligent. Right? That's the point.
Thank
Right.
you, Francisco.
Thank you so much.